Good morning. I'm very glad to see you again this year in the Luxembourg. This year I will speak about the trace service and the audit feature first introduced in the 5.2.5 Firebird. Well, in this session we will speak about what is trace services, how it works, how it implemented, how it organized inside the engine, how you can use it in your application, and we will look at some typical use cases. We'll speak about the system audit and about user trace sessions. The key moment in this new feature is the trace session. What is trace session? The easy way to implement ability to trace some internal engine events will be to create some configuration file and to let the engine or the server to put corresponding events into some kind of the log file. But this is not very usable and not very interesting from the end user point of view. Our goal was to make tracing easy and to make tracing very customizable. Also, it was a very important requirement for us to allow different users make its own tracing at the same time, to not mix different events on the different user needs. So we want that one user can specify its own trace parameters and another user can specify what they want to trace and so on. So we introduced the trace session. Trace session is a kind of database session. For example, with database attachment, you can issue your own queries. You can identify your database attachment. In the same way, trace session also can be identified. It has ID assigned by the engine when you create the trace session. You can set name for this trace session to more easily distinguish it from the other trace sessions. This is optional and not necessary unique characteristics. Also, engine track which user created the trace session and date and time of when this trace session was created and started. The second very important characteristic of the trace session is its configuration. Configuration of the trace session consists of mostly two parts. The first part is what database or maybe Firebird services you want to trace, and the second part is which events and how detailed information you need about these events. So what exactly you want to trace. The next characteristic of the trace session is its scope visibility. For example, right now we have two kinds of visibility of the trace session, what it will trace. The trace session created by the system administrator have access to all the events in the whole system, in the whole Firebird processes, and it will produce events by the all attachments in the system. But if a trace session was created by a regular user, it will see only events which happens inside its own attachments. It's the obvious security requirement. Trace session also have its state. It could be running or it could be suspended. If needed, user can suspend and resume its own trace session for its own needs. And the last but very, very important characteristic of the trace session is where these events are accumulated, where it's stored. This is the so-called output of the trace session. It could be tuned by the different ways, and we will speak about it in more details later. So let's speak about trace session configuration. This is the first and most visible part of the trace session which user will see. Trace session configuration is just usually is a text file. It consists of few sections. You you can find this text file in the root of your Firebird installation. For example, I have Firebird 2.5 installed here, and trace conf is the sample trace configuration. This is the self-documented file. You can read it when you need. So it's usual configuration file as used by Firebird. It have commands inside it. You can see this is the documentation in this file, and it consists of few sections. Default database section with parameters for every database which will be traced. This is the end of this section. Default services section, which lists parameters for the traced services. And if you want, you could specify additional database sections to specify parameters for some particular database or databases. Next slide. Database sections could take parameter, database name pattern, which is could be or the whole path for the database or database alias, or it could be a regular expression which is used in the Firebird in the, for example, similar to predicate. So you can specify in default database section common parameters for the old database tracing unit in and override these parameters for some particular database. A bit more about which parameters we have. In section database we have some events which is related to the connection and transaction. We could enable or disable log connect and disconnect calls using the log connections boolean parameter. We could filter trace session to trace the events from the particular connection. If you know attachment ID of the some attachment you want to trace, you don't need to trace the whole hundreds of attachments in the system. You could limit the scope of your trace session by this particular attachment. For example, you debug something and you want to know events in this particular connection. Log transactions allow you to enable or disable records about transaction start and transaction finish. Transaction can be finished by commit or rollback. This is explicitly distinguished by the trace events. And relating new parameter which was introduced in the 2.5 to 2.2, which is about to be released in the next few days, is the log sweep. Log sweep allows you to see events about when sweep starts, how sweep progress is done. It will put event for the every sweep relation, every sweep relation table, and you could see the how many records was cleaned and so on. The next group of parameters is related to the SQL statement. The log statement prepare, free, start and finish parameters correspondingly allow you to see events when the some SQL statements is prepared by application, when it's freed, when it started execution, and when execution is finished. Also, we have two filters, include filter and exclude filter. This is the regular expressions, and you could compare it against the statement text. For example, you want only select and you don't need anything else. Or you have special, you could include special markets in view queries, for example, in like a comments, and you can include this include filter to filter only that statement that you need to trace. Also, there is a boolean parameter print plan, which allow you to see the plan of the SQL statement or to not see if you don't need it. The some events, a group of events, is related to the procedural language. You could see every procedure start and finish, and every trigger start and finish. When you run, for example, select from procedure, you could see the statement select from procedure if you include it in the previous group of parameters, and also when the statement really opens this procedure to execution, you could see the corresponding events about this particular procedure start. In this event, you could see the procedure name, you will see the parameters which was really used when procedure start, and so on. Log context allows you to see calls for the RDB set context, and I don't remember exactly RDB head context calls. I don't remember exactly now. The next group is about old DLR API related events. If you never used preprocessed application, you don't even know about this API, but for example, audit requirement, you need to know all events which could be happens in the database. So in some cases, this calls also should be traced. So we could see the DLR requests. For example, if you run ISQL and if you show version command, you will see some interesting information. Probably you never see it before. And print DLR allows you to print or to not print text representation of the use of DLR statement. DIN request is the acronym for the dynamic execution for DDL request, which could be also issued using this old API, not like an SQL statement, create table or so on, but using the special DIN language used in the old version of interface. Separate parameter printer is used when you want or you don't want to see performance related information. For example, when the statement finished or when the transaction committed, Firebird could print for you corresponding performance statistics. This is like the statistics which is printed by ISQL, for example, when you set that on, but it could be with more details. There is also various restrictions which allow you to some level control the size of the trace log and what you want to trace and what you don't want to trace. For example, time threshold allows you to set the minimal time in the milliseconds, which will filter out, for example, short or long statements. If you set time threshold for the 100 milliseconds, it will not trace the statements which was completed less than this value. Also, if you have max SQL length parameter which show how many characters from the SQL statement text could be put in the traced events. For example, you can have very long SQL statements, and it could easily overfill your trace log, and you don't want the whole the statement. You can limit, for example, by 2,000 or 3,000 characters, and engine will print just the first max SQL length characters from the SQL statement text. Max arc length is about how many characters from the statement or procedure arguments will be printed in the event log. Max arc count also limit how many arguments will be printed. For example, if you have procedure with a few thousand of parameters, crazy but possible, you not obliged to trace all these parameters if you don't need it. You can print only first 10, for example, how you need it. Max DLR length and max DIN length is limit for the DLR and DIN representation text in the corresponding events. This is about trace session configuration. As end user, you will mostly work with this part of the trace service. This is the most visible part. So I decided to speak about it in such details in the first place. Oh, also we have section about services. The services, we have two kinds of events. Log services is the Boolean filter allows you to log or not log some services activity, and log service query is about details. For example, some service you could query contents of the services, for example, take the Firebird log or take the log of the backup, and you could or could not log these queries to the service. Include filter and exclude filter allows you to set which exactly services you want to trace. For example, here the list of the names of the Firebird services which is used by the engine internally, and using include filter or exclude filter in the services section you could specify what services you want to trace. For example, you want to trace only backup database service, or maybe you want all the services except the trace session services, or so on. It's all about configuration. No, it's not all. Sorry. Well, there is few parameters which is common for the both database and services section. Common in the sense that both sections will have parameters with these names. The parameter enabled set if we want to enable or disable the trace particular database of services. For example, if you don't need to trace services and you want only trace database attachment, you create the services section and put enabled false, and that's all. You will not see events about the services. Log file name and max log size specify the file name where the audit trace session will put its contents, its events. I will speak about audit trace session and about its log file in details later. And log errors allow you to log or don't log errors which happens on the different API call. It's also a new parameter. It was introduced and it will be introduced in 2.5.2, and it allows you to see what errors happens inside your application if you need it. Yeah. Well, there is two kinds of the trace sessions. This is the two very different kinds of sessions, and I decided to show the difference in much details. We have two kinds of sessions. This is the user trace sessions and the audit trace session. User trace session is the trace session which was initiated or created by the user itself. So you wrote your own application, or you use standard application, you start the trace session, you read it log, and you end the trace session. This is what is so-called user trace session. And there is special kind of trace session. This is audit trace session. Audit trace session always created by Firebird engine. You specify in the special file configuration for this trace session, and it's used for the long-term purposes. For example, if you need really audit, or you need to take statistics of the all events in your database for the long period of time, it is preferable to run audit trace session. It put its events into specified log file. You don't need to run special application to read this log file. It will be accumulated in the place you specify in configuration. And when you decide to stop this audit trace session, you stop it and process logs which is accumulated by it. So the differences, as I already said, user trace session initiated by the user. but audit trace session is started by the Firebird itself. User trace session can be preserved after Firebird shutdown. So if you start the user trace session and server was reloaded, this user trace session will not be started again. It's ended. If you need, you should start it again and run and read the output. But audit trace session can be killed. It started every time when the Firebird is started. Output of the user trace session must be read by the service connection which was created this trace session. I mean, if you run application which creates the trace session, this application must read the whole output of the user trace session. When the application don't need this output, it just stop user trace session and that's all. For the audit trace session, there is a different story. It's started by Firebird and its output is accumulated forever until you decide to stop audit trace session, and output is accumulated in the log files specified by you in the configuration. Visibility scope of the user trace session depends on the user which is started the trace session. If this is ordinal user, it will see only the events produced by its own connection or attachment. For the audit session, there is no such limitation. It will see all events in the system. User trace session could be temporarily paused by Firebird. What it means? As I already said, application which started a user trace session should read this output, but application could read this output slower than server produces these events. So, in this case, when some internal buffer is overfilled, server decided to pause, to suspend the trace session by this user, and application will read over the accumulated events, and when the space will be freed, server will automatically resume this trace session. For audit trace session, this is not the case. It's never interrupted by Firebird. So if audit trace session, for example, logs written on disk is slower, it will slower all new database server. It will wait until the audit logs is produced. Also, could be many user trace sessions. Ideally, every user could decide if he needed, it can start its own trace session or many trace sessions with different configuration and work with it. But audit trace session could exist only in one instance. Also, user trace session could be managed by user which created it or by sysdb. Manager could suspend the user trace session, could stop it. But for audit trace session, this management could be done only by sysdb. Well, what is trace session and how it appears in the engine, how it creates and how it looks like? We will speak now mostly about the user trace session, but for the audit trace session, the mechanism is almost the same. So when the application using the trace services decided to start some trace session, it run special Firebird services which will deal with so-called trace configuration storage. Trace configuration storage will accept parameters from the application and will create stored session record. There is special storage where all the session records is stored and could be accessed. Every database attachment or every service attachment have special object called trace manager. This trace manager also works with trace configuration storage. When trace manager detects that trace configuration storage was changed, it consulted and it looks at the storage session record, and if it is necessary, it creates session object in memory, and this session object is that object where the trace manager passes events happens in the database. So There is a central storage of the trace configuration files, trace configuration parameters. It have session records, which have all the characteristics we enlisted before. It have trace configuration, it have trace state, and so on. And trace manager in every database attachment have its own list of the session objects. Few words about trace configuration storage. This storage is made very simple. We have choices how to implement it. The choices who we was considered was the database storage or maybe set of files or so on. But database storage was not agreed because we have in Firebird central database where we can store all this trace configuration. Because trace is not about work with the some particular user database. We should have a configuration storage separate from any user database. By some reason we decided to not use a security database. One of the reasons is that in the Firebird 3 there will be no central security database. So at the final step we consider to implement very simple file-based storage for the trace records. So this storage consists from the two files. The first file, fbtrace, is a control file. It's very small, just a few bytes. This file is mapped into the shared memory. Remember, we have the classic server, we have the embedded processes, so we must something which could be shared between all these processes. This file is controlled, have some parameters common for the configuration storage. I will speak about it in the next slide. And there is actual file, fbtrace, with some suffix, random suffix, and this file is really stored all the trace session records. Both files placed at directory where Firebird take a log files. By default, this is common app data Firebird. On Linux, it's somewhere in the tmp folder. If I remember correctly, it's tmp Firebird. This configuration storage creates when any Firebird process starts. It's storage shared by all the Firebird processes. Node embedded processes also play in this game. And this storage is deleted when the last Firebird process is gone. This is the reason why the user trace session can be preserved between Firebird restarts. Because when last Firebird process is gone, the configuration storage also is emptied and deleted. The picture may be too easy to understand what is the control file. As I already said, it has just a few bytes, it has its version, it has three very important characteristics. The change number. Every time when config storage is changed, for example, some trace session appeared or disappeared or maybe changed its state, this change number is changed, is increased. Number of the last session, this is the generator from where the trace session obtained its ID. Count uses, it's used to detect if configuration storage should be deleted by the going process. And config file name, which points us to the real configuration storage file, where the session records are stored. Well, how Trace Manager detects these changes in the configuration? One of the way obvious but very not efficient is the Trace Manager could constantly ask storage, are you change it, are you change it, are you change it. This is not the way, this is not efficient. Less obvious way is to create some kind of signal mechanism, and trace storage could wake up the trace manager in every process and notify it about its changes. But we decided, as we think, the most efficient way. As I said above, the trace configuration have a special change number. Trace manager in memory also has the change number. This is the change number is obtained from the trace configuration storage last time when trace manager updates its internal list of the sessions. So when some event traces happens inside the engine, trace manager at first step compare its own change number and change number of the trace configuration. If it's equal, then all okay, and trace manager could pass event into existing session objects. If no, trace manager should update its own list of the sessions and only then pass these events into the corresponding sessions. This is in more details how it happens. Again, trace configuration storage have its storage session record and have its change number. Change number in the trace manager is different, so trace manager should update its session objects internal. At first step, trace manager creates special trace and info structure and passes it into every trace plugin which it could find. Trace plugins is the shared object DLL on Windows or so on the Linux. This is the DLL of the special format. It's placed in the plugins subdirectory and it should export special function trace create. So trace manager create initial info, trace init info structure and pass it into every plugin it will find. Plugin can obtain configuration text from this trace init info. It have trace session name, it have database name, for example, and trace plugin will decide if it want to trace in this environment. So, for example, trace plugin look at the configuration text and looks in the database section and compare database name with database pattern and decide if it want to trace this particular attachment. If yes, trace plugin returns a special object trace plugin and trace manager add this object into the session object its own. If not, trace manager just mark this session record inside its own as not usable and will not pass events into this trace session. Not sure if it was really clear. If you have questions, ask. Well, why I speak about it? I want to underline that we trying to create a first efficient way to change, to detect changes in the trace configuration, and second, we want to create a flexible way to make the tracing itself. We move all the important functions about creating trace events, formatting trace events, loading trace events into the trace plugin. We create our own trace plugin, which put database events into some kind of text form. And I know currently at least one implementation of the trace plugin which is not standard. IB Surgeon could speak about it. If you want, Alexei will speak about it. And this trace plugin have much more abilities than our own. For example, it could put events not in text files but into the Firebird database. It could produce some kind of binary format and so on. So if you want, you can ask Alexei and it will speak about it more. Well, I speak about trace session output. And trace session output is also very, very important thing. We now know how events burn inside the engine, how it going into the trace plugin, but we still don't know how the application is obtained. Trace plugin, with help of the engine, put all the event in the some kind of representation. In our case, it's text representation into some place. For the user trace session, engine put all the text events into a set of the text files, which also put at the Firebird log directory. This is the temporary files, and trace session, trace service which was initiated. Trace service should read all this data to allow engine process more. So user trace session have many writers. This is easy to understand. How many attachments we have is every attachment or every service attachment will produce some events. And these events go into the trace session output. For the audit trace, it's the same. For user trace, we have exactly one reader. So events are accumulated and it reads by the user application which starts the session. For the system audit, this is not the case. There is no readers. The events just accumulate in some text files. For the user trace session, this space is released while reading. So when user application reads some amount of the trace log, this space reserved for is released. But for the audit trace session, again, this is not the case. Log files never destroyed by the Firebird itself, but you can tune the log file's rotation. Rotation means that when log file reaches some size, it will be renamed and a new log file will be created on its place. With renamed log files, Firebird have no links, and this file could be removed by administrator, it could be moved into another place, and so on. For the user trace, when a reader or user application is gone, the whole log is deleted. For the audit trace session, this is again not the case. Log files never deleted by the Firebird. It's up to the system administrator. For the user trace session, log files where the engine places events is set by Firebird. This is internal thing. And for the audit trace session, log file name is set in the trace configuration in the per database basis. If you remember, I speak about the common parameters. This is the log file name, and max log size. This is for rotation. This is the log file name where the audit records will be placed. So, this is the picture to maybe make understanding a bit easier what is output of the user trace. A user application starts the trace session issuing IC start service call, and then it's constantly read the output of the trace session using IC query service call. The service attachment in the left part of the picture is the service attachment which created the user trace session. It has a trace manager, of course, inside it, and it also produces some events. Maybe for this trace session, maybe for something else, maybe nobody can read these events. And it constantly reads from the log files, which is produced by writers. This is the reader, and in the right part of the picture, we see the writers. It's every database attachment, a service attachment, which have corresponding session object, and it produces events and put it into the log files. This log files is internal for the Firebird. User trace. This is also a set of files, output of user trace, and here I want to show how it's organized. There is also a special control file which is also put into the shared memory. Why we need shared memory here? Because we have many writers and one reader, and it could be in different processes. For example, for the embedded case or for the classic case. So we need something in shared memory. Every user trace session have assigned guide, assigned by the engine. This guide is in internal thing, and if I remember correctly, you can see it in the trace records. But we needed to distinguish the output of the different trace sessions. So every trace session file of the output is appended with this guide. And log files where the actual events is put is the set of files. The maximum file size of each log file is 1 megabyte. And when first file is reached its size, engine creates second file and so on. By default, engine could create no more than 10 such files. When 10 files is created and user application is still not read the first file, engine will suspend putting events into this particular trace session and will wait until application started by user will read the necessary info. When the application read the, for example, contains all context of the first file, it will remove this first file and session will be resumed. Of course, it's not necessary. Application could read events fast, and there will be never 10 files at the same time in the temporary directory. For the system audit trace, the things is much easier. This is output of this audit trace is stored in the disk file. We saw where the file is placed. This is the parameter of log file name in the database or service section. And only customization is that database or service could have its own trace log file. Because log file name also could be the pattern. Here we have example here of the log file name where audit session for the every database will put corresponding events into the different log file name. This is the more easy topic. So I finish it with internals. If you have some questions about internals, you can ask it now. Else I will speak about the applied part. So to manage trace sessions, we have created special new console application with Trace Manager. The Trace Manager put into the game root of the Firebird installation in the bin folder. Here it is. I will run it, and it will speak for me what it can and what it can. I don't know if you can read it. So this is the parameters of the Trace Manager. It has some actions. You should specify at least exactly one action to run. You can start trace session, you can stop trace session, suspend or resume existing trace session, or you can enlist existing trace sessions. Some actions have parameters. For example, when you start session, you can specify session name, and you should specify configuration for this trace session. The Trace Manager utility works in this way that you specify trace configuration file name, so you don't need to specify the whole trace configuration in the command line. Of course, it has connection parameters. This is the command for almost all utilities. You could specify username and password. You should specify service name because this application to work with the services API. And here is the example how to run it. This button. This command will connect to the remote host with user CDBA and will ask for the list of the active trace services, and so on. This is very simple. There is at least two beautiful utility in the market which allows you to work with the rich GUI application. This year, Thomas Stenmauer can't go into the Luxembourg and speak about it, but I really suggest you to look at his FB Trace Manager application. It's very fine. But if you need something simple and work right now, you can use our FB Trace Manager, and at least you can see what trace services is allowing you. Also, for example, IB Expert have support for the trace utilities, but it's somewhat limited. And in your own application, you also, it's not a secret, you can also create your own application if you program it, and you can customize it as you want to, maybe to analyze something or to work with the trace services. I want to show a little example how trace services output is read by the Firebird itself. I won't prepare example in the Pascal language, which is maybe more easy to understand and more popular, but I think this is C code is also not very hard to understand. So at first we should start trace service. This utility have service parameter buffers already prepared for this, and then in the endless circle we should read the trace output. Our utility trace manager uses IC4SVC to EOF, which allows you to read the not just line by line. It will be very slow, but it allows to specify a relatively large buffer and put it to the server and ask it to fill as much as possible in this buffer. Size of the internal buffer is 16 kilobytes. So if engine produces many amount of data, it will be read by this 16 kilobytes chunks. Then we call service query, and this is was somewhat dark part, in particular for me before I start to run to work with these services. We can specify the query which we run about the service. This is the query. This is the item we want to read. Also, there is special send items, and we put here timeout. Timeout with 1 second. This means that if there is no events on the server side, it will not wait forever, and it will, after 1 second timeout, return empty buffer for us. This is done specially to have ability to stop waiting. For example, this is the interactive, this is the user utility, and user don't want to wait forever when the some events appear. And in this application, we allow to press Ctrl+C, and it will stop service query. But this is very simple. This is not a multi-threaded application, and we want some ability to break the circle of the endless waiting. So we use 1 second timeout here. When service query returns, we analyze what is returned to us. It should return when it have some data for us to return. It should return at first item the text which we specified in our query. This is an IC info service to EOF. We interpret the output. We extract the length of the output using IC into the call, and we just print corresponding number of bytes on the console here. Of course, if engine have more data that that could fit in our 16 kilobytes buffer, it could return IC for truncated code. We should distinct where this truncation occurs, because we have some errors, or because buffer really was truncated, because there is more data that we can fit it in here. So we have this flag ignore truncation, which is set to true when we read the correct text at the first place. If server just returns info truncated, but it don't return to us info as we set it off, this is some error, and we should break this trace session and return error to the application. So this is the general circle, how it done. This is how we handle timeout or data not ready states. If we have timeout, we understand that trace session is not stopped by the external facility. For example, if our trace session will be stopped by the external application, it's possible, and then we have a server will return to us data not ready, and will return to us info truncated, and we will stop our endless circle. Well, I almost finished. If you have questions about it, or maybe about some slides, then I will be glad to answer to you. Alexei, want to add something? Maybe about its own plugin?
Sometimes we'd like to add some words about plugin implementation that we made using the sample implementation that Vlad and team provided. So it's just 2 slides. There will be much more such available APIs, so we will be able to create plugins for more points in the engine. But since it's already available in 2.5, why not to create a plugin? So we fulfill and we create it. Actually, from the user's point of view, the plugin looks very simple. So you just need to delete the standard DLL plugin and put our plugin into the appropriate folder in Firebird and configure it to add parameters into integration file. There are only actually few parameters. The first is the export data type. Export standard plugin can write only to the plain text, and we have the export data type 0 for the plain text, which is exactly the same what the standard plugin has. Another data type is the external table. So the Firebird recipe output can be written to the external table. And the first, the most useful one, is to write to the native Firebird database log. As you can see, the Firebird destination to the log can be on another server. So you can configure one server for its production and put the log somewhere to the network and store it. Another big improvement that we made, we have created the cache for the output. The problem that Vlad refers to about the Firebird freezing when there are a lot of trace events generated. It can be there is a workaround to create bigger write cache. And also we have separated internally in the implementation the write mechanism. So writes now asynchronously, and write plugins are being transferred to the Grouper, and after that Grouper flashes into the external storage. So it's very easy to start. It's compatible with the system API, and it can run on Windows and Linux. And just once that we want some beta testers, and if you want, just write a mail to beta@ib.com and get the plugin. Okay, that's all my addition. Thank you. Yes. I know that our plugin cannot work together with the standard one, but in general, I think that Vlad can better explain how several plugins can work on the Trace.
So this design is in this way that many plugins will run at the same time. But in this case, it's just not necessary. If you want, you will produce both the block and custom log, but it will mean you have additional performance penalty, and you will have additional space requirements. So if you want it, you will. So no problem. And as I remember, only problem that could be if you have custom configurations for the custom plugin, Firebird will complain about unknown words. So Firebird plugin will not work with the configuration which you can't understand. We have no way to file this plugin to use when we start the trace session. To start the trace session, we put the configuration text in the trace table, and at the engine side, this text is passed into every plugin. It's the same text. Well, we have in mind this issue, and we probably will extend trace session start parameters, and we will specify this plugin to use. But this is to be discussed because so far we have trace services for the 3 years, but only half a year ago we see the first custom trace plugin. So we can expect some conflicts or some clashes, but we have it and we will solve it now. Yes, number of events is into the engine, and does not. It's not defined by plugin. It's engine which has some hooks. No, but if you have an idea what it is like, you can find this idea, and we have Firebird 3 and we have plans to extend traceability. So just probably it would be a good idea to discuss it maybe inside the mail. And when we have some agreements, we of course put it in the letter.
don't hear. I understand the question is funny, but I don't hear it. Sorry. I asked you. No, we don't have such question. It's like the back itself. Well, that's no, I think the first goal is control Windows, Linux. We have tested it on the DCC environment after 200 connections. Well, I think that it will require some experience with my developer. And for I feel 1 month here, but my personal impression that not so many people can find it online. I know that I don't know. Well, we can discuss it and see how we can manage it. I see only several hundreds of words a year. Last time I checked, well, that's good, but I think what we need to define the majority of people more. So, any more questions about traces? But I think that I have an impression that people just don't understand how easily the trace and discover the problems in own code to find out what's happening, what is the best line, what is the best one, and it can run right on the production without investigating the source code of something. You just, don't know, there's not much experience in that kind of development. Maybe it's because the Firebird is too good and it works without any design and tracing. Just pick some magic buttons, maybe parameters, Firebird can fix it, it will run like a rocket. Actually, the mid tracer is there. And if it's stuff, there is no question. Thank you for listening.
I